Welcome back. Today we're going to dive into a core concept in the field of automation, the PID controller. PID stands for proportional, integral, and derivative. Simply put, if you need to keep a physical quantity constant, such as temperature, pressure, or flow, PID is the best tool for achieving this goal. As shown in the coordinate graph on the side, adjusting the output curves for different P, I, and D values will yield different results. The core of PID lies in control loop feedback. Its working logic is simple. You input a set point into the controller, and the controller adjusts its output based on the feedback from the sensor, ensuring the actual result matches your desired target. No matter how the external environment changes, it maintains the stability of the system through constant correction. Take a common industrial PID temperature controller. After setting the target, the heater runs until the sensor feeds back that the temperature is reached. Then it stops. When the temperature drops, the heater resumes to keep the value within a tight range, constantly ensuring a steady temperature. To better understand, consider a car's cruise control. The ECU acts as the PID controller. You set the speed, set point, and the speed sensor provides the feedback. The system automatically adjusts the throttle, accelerating if too slow and easing off if too fast, a classic PID control process. In industrial manufacturing, the temperature controller is the most common application. We set a target 200 degrees Fahrenheit, and a thermocouple provides feedback. The system maintains stability by continuously switching the heating on when the temperature drops below the set point and off when it rises above the limit 200 degrees Fahrenheit. This constant monitoring and on/off switching is the most fundamental form of PID control. Beyond standalone instruments, we can also use a PLC, programmable logic controller, to implement PID control. In this scenario, we use the PLC's existing input cards to read sensor data and its output cards to control the equipment. All the calculation and decision-making logic are performed by the program inside the PLC. This not only saves hardware costs, but also makes the entire control process more intelligent and flexible.